Good morning or good evening. For me, it's evening. The clock is about 4:30. It's dark outside. We have a little bit of snow, but it's fun that we can join to have this event now. We keep up with persons all over the world. My name is Hindrikes. I'm a Xamarin developer based in the middle of Sweden, working with a developer and architect for mobile cloud solution, doing a lot of Xamarin stuff, Azure stuff, and working for a consult company where I'm doing a lot of that stuff. I also have written a book, Xamarin.Forms Projects, together with my great colleague Johan Karlsson. We also used to do some podcasts, mostly in Swedish. Most of you maybe not understand what we are saying, but I also have started to do some Twitch streaming. So just search for my name on Twitch. You will find my channel. And there will be a lot of more streams in the upcoming months than I have done before. But today I will talk about Azure SignalR and how you can use that in your Xamarin.Forms app. And I will also touch Blazor a little bit because I have a sample app where you can use the same SignalR services for both Blazor and Xamarin. So if you want to learn more about Xamarin and also about Xamarin and SignalR after this session, one of the chapters in our book is about how to set up the SignalR service and how to configure it and how you can use it in your Xamarin.Forms apps. It's step by step, so it will be very easy to follow. I also have a shorter blog post on my blog about how to do it, but if you want to have step-by-step introduction, I recommend you to buy our book. It's available on Amazon. You can buy it directly from Pact and other places where you can buy books in printed format, or you can even buy it as an ebook. So today I will talk about Azure SignalR Service. We will not do as much of PowerPoint. I will focus mostly on demos, both in the Azure portal or in Visual Studio. But first, I want to talk a little bit about what Azure SignalR Service is and when to use it. We have had SignalR for many years. You can use it in your ASP.NET Core application, host it yourself, or host it in your services in Azure. But then you need to dedicate resources and things like that. But for maybe it's about a year ago, Microsoft released the SignalR service, so you can have it like a serverless solution. So that's what I will focus on today. If you don't know what SignalR is, it's a service and a library for making live updates in your application. So you can, for example, have a web application getting live updates via WebSockets. There are also fallback options for long polling and things like that. So if the device and browser don't have support for WebSockets, but I guess most of the browsers and devices have support for that today. So when to use it in a mobile app, because we have maybe three options to get live updates. We can long polling, or we can have polling a server every second, but that's not a nice solution. We will have a lot of we'll have a lot of calls that we don't need. So then we can have push notifications. Push notification is great for live updates if we don't have the app open. But if we have the app open, we want to have immediately update the resource. For example, if you have a live feed for a sports game, a hockey match, or a football match, or if we have a dashboard, we can maybe have an Azure dashboard so we can monitor our resources live. Then we can use SignalR to get the updates, or other dashboard applications, or everything that needs to be live. SignalR is also used if you're using Blazor server side, so it's a widely used technology. So let's take a look about how you can architecture app to get a little bit of a view how the serverless option of SignalR service work. So I created a lot of different arrows, but in the right corner, up in the right corner, we have different type of clients. It can be a native app, it could be a web application. It doesn't depend on what technology you're using to build your applications. It can be a React web app, it can be a Xamarin app, it could be a Swift app. There are libraries for most of the most popular languages, so you can use it together with SignalR. But if we, for example, take a look how a message will be updated on the device. So we have the SignalR hub. For example, we can have a live hub, or we can have different topics in the hub. Then we will send a message to it, and then it will send it to all connected clients. So there are different ways to do that. If you want to have a serverless solution, I recommend to use Azure Functions, and that's also what I will show you today in my demo. So from the Azure Functions app, there are different ways to get the message to the queue. We can have a trigger, for example, listen to a service bus when something happens. The Azure function will pipe it to the SignalR hub, or we can have a database, a storage, and have a bindings to that, because Azure Functions, that you maybe know, have a lot of different bindings to different other services in Azure, so they can trigger automatically without you having to invoke it yourself. But we can also invoke functions, for example, from a web app or from a native app, and that's what I will show you how to build today. We also have a function in the Azure Functions app that is returning the connection information for the SignalR hub. Because to access the SignalR hub, you need to have the URL to it, and you also need to have an access token. And the easiest way to do that is to set up a function that returning the token to the app or the web application, because it's not recommended to have it in the app when you deploy it. It can be changed, but it's not that secure to have keys in your application, because they can be you can lose them to people that don't need to have access to them. And Azure Functions, then you can protect with different authentication layers. You can use what they call easy auth in Azure, for example, or you can have a function key. It doesn't matter what you have. It's what's supported for all Azure Functions is also supported now, so you don't have to care about that. So let's dive into the Azure portal to create a new SignalR Service app. Just need to find my browser window. Here it is. So here is the Azure portal. So we will create a new resource. We will search for SignalR Service. I will create a new one. So here are some basic information you need to fill in. You need to select a resource group. Of course, you need to give it a name. MonkeyFest demo. Region, West Europe is the data center closest to me, so I will select that one. Then we also need to select a pricing tier. And we have one free tier that is enough for development and test. You can probably use it for smaller applications as well, but you can also only have up to 20 connections. So if you have more than 20 connections, that means concurrent devices, and then you don't are able to use a free tier, and you have no SLAs, and you have a limit of 20K messages a day, compared to the standard tier where you can have 1 million messages each day. You can have 1,000 connections per unit, and you can have up to 1,000 units. And you also have SLA, and yeah, here is a cost in Swedish crowns, but it's about $40 in the month per unit. But we will create a free one for this, because if I don't remember to delete it after the session, I don't have to pay for it. Then we can have different service mode. We will use serverless. Then we will create a new one. So now it's validating our settings, and now we can create it. But we don't want to wait for the deployment. It will just take a few minutes, but it's boring to looking at that window. So I have prepared and create one before. So we can access that one here. Live sample. So here you can see how many connections, you can see message count. But what we want to have to be able to start working with, we need the connection string. So here we have keys and you have a connection string. And you can also, if you want to regenerate them, if you lost a key, for example, you can go here and regenerate it so you can replace it in your application. I also have created an Azure Function app. And here is the place for us to put our connection string. So if we go here to configuration, it's not that fast today. Then we will inject it in a property here called Azure SignalR connection string. And then it will be picked up automatically. So let's take a look about how my sample application will look. So we'll go into Visual Studio. I have a solution with an app built for iOS and Android. I have a web application built on Blazor Wasm, and I have the Functions app and also have a shared project for some messages. So let's start the web application just to see how it will work. We can use Google Chrome, deploy, and here I have the iOS simulator where I already have deployed the app to. Okay. As you can see, I'm not a designer, but that will be work for our sample. So here is the app. I will enter a name and I will connect to a live feed. So here I have the web app where I can have updates and I can in the app I will get the updates, and I can also comment in both the app and on the web page. So we can say that the home team will make one goal. I can update it. It will update more or less immediately on the mobile device. So if we go, and I can also add a comment, goal by Peter Forsberg, an old Swedish hockey player. Then comment here. And you can see that the updates they are really fast. So this is a Blazor app, and this is Xamarin.Forms app. So let's take a look how that is built. No, I don't want to update Visual Studio now. Functions. So here we have the get info function, and that's the function that returns the connection information to the apps. So just the HTTP triggered function. In this case, I have anonymous access on it. It's probably not recommended in production environment, but for this sample it's enough. And all this code is also available if you go to my GitHub account. I can show you the username for that. It's the Hindrikes/live samples. So here are all the code if you want to try to run it yourself. Probably you need to create an own, not probably, you need to create your own service in Azure, but you can do that with a free account, for example. If you want to run the functions locally, if you, for example, want to debug it, you need to add the connection to a local settings.json file. I don't have one in this case, but you can add that yourself and have all the configuration there. So what we are doing in this function is that we have a HTTP trigger, but we also have a binding like this. We have injecting a SignalR connection info, and we set a hub name, in this case to live. Then we just return connection info, and this is what Azure function called binding, and you will get them to SignalR Service if you install the NuGet package that is called Microsoft Azure Web Jobs Extension SignalR Service. So then we have a function that I call add message, and that is a function that is called when we, for example, adding a new comment here. Being autocorrect can be strange sometimes, adding comment. So, and then this function is called. I have defined a couple of messages that are used to send a message across the SignalR hub. I have them in a separate project here, so I can share them between all my .NET applications. So I have a comment message that have a name property, and I also have a base class message that have text type info, and type info is what type of message you're sending. In this case, I'm using just the name of the class. I will show you later where I use that. Then I also have a timestamp. I don't use that in my app right now, but it will be good to have. But here you can see when you're adding a message to the SignalR messages that you also inject like you did with the SignalR connection info. You add a SignalR message and a target. And in this case, the name of the class is the target, the type info. Then you have arguments that is the actual message. So in this case, I get a JSON object from the clients. I deserialize this to a message object, and then I put it into the queue. If I need to access some more information about it, I can do that. For example, then I need to check if it's a comment message, for example. I cannot do like that. I need to do if message punct type info name of comment message, and I can do like this, and then I can serialize it to a comment message instead. But if I don't need to access properties specific for the comment message, I don't need to do this. And this is also the case that I don't have made the message base class abstract, because if it's abstract, I cannot deserialize to be that type. But here, for example, we maybe want to add some checks if the message are okay, if it's so it not contains ugly words or whatever you want. In the book, the project we have there, we also are able to upload photos to a chat, and before we are adding the photos to the queue, we are scanning them with Azure Cognitive Services to make sure that there are no adult content in it. We have a question here. How will you reference this function project in Xamarin main project? We don't reference the function projects. We're making HTTP calls to it. So we deploy it to Azure, and then the clients are talking to it with HTTP. But we don't need this code for the sample, but it can still be left here. So then we can, the last thing to do is to add the message to the SignalR messages collection. Then it will send it to the SignalR hub, and it will update devices. When we want to connect to the hub, we will do the same both in the Blazor project and in the Xamarin app. So if we take a look first at the Blazor app, this code is possible to share if you want to. I didn't do that in this project, but because it's easier to show each project and have all the code available there. So when we have this view loaded, this initializing method will be triggered. Then I will create a new HTTP client. Then I will call the Azure function with name getInfo, and I will get back the connection info from it. And connection info is a class that I have defined in my message project. It will have a URL, and it will have an access token. And with that, I can create a hub connection. To get those classes and objects, we need to install the project, a NuGet package called Microsoft ASP.NET Core .SignalR.client. So that will be the package containing all things that you need to use SignalR for both the Xamarin app and for Blazor, because it's just the .NET standard library, so you can use it on all your .NET clients. Then we have creating a connection builder that we will send some options to, and we will pass the token to it like this. So with the URL, pass the URL, have an action here, and we will provide the access token to it. And then from the connection builder, we will build it, and we will get a hub connection that we can start listening to messages for. So in this case, we only listen to comment messages. So then we use hub on, where we will have an object back, and here we'll pass a string. So in this case, it's what's called target type in the Azure function. So that will be the name of the message. So we're using name of comment message. Then we will have an action here, and that will run every time we will get a message back. So we will deserialize to a comment message, and we will insert it into the comments list that is the list that we have up here, that looping out the messages on the screen. So it's very simple to get started with this, and you don't need that much code. But the last thing you need to do before is you get some messages to call start async. So that's how we're sending messages, listen to comments in the Blazor app. When we're sending messages, we just use an HTTP client and send them to the Azure function like this. So let's go to the fun part, the Xamarin.Forms app. This is an app built for iOS and Android. I will only show the iOS version now because it's much faster to deploy and debug on iOS, I think. So I have two views, two view models, and a main view and a live view model. And it's in the live view model, everything that interesting happens. So I have set up some properties that are the actual information on the screen that I have bound the UI components to. Then I have an observable collection for comments. Then I have some logic for sending comments, and you can see that this code is very similar to the code I had in the Blazor app. It's more or less the same. I post the comment to the function, and the function will send it to the SignalR hub, and it will update all connected clients. So that's it. And in view model here, when we start it, or when it's initialize here is handled by Tiny MVVM, my own MVVM library. So if you don't wonder what initialize is in the view model here, so we're creating an HTTP client here too, and then we will call the getInfo function. We'll get better connection result, and we will create a connection builder exactly as within the Blazor app, but we will build it and to get the hub. And here we will have two different messages that we are listening to. We're listening to a result message, and we're listening to a hub message. We can also have one common channel where we're sending different types of objects, but I think it's much faster to do like this, and it will cleaner code if we have one channel within the same hub, one target type, if to use the correct word for each hub. So we have one target type that is a result message, one is comment message. So we have a clean code when we handle it here. So what I did here is to deserialize the object to a result message and update home goals and away goals. And so simple as that. And the comment message we deserialize to a comment message, and then we insert it to the comments observer collection. And I'm using insert here instead of add because I want it at the top of the collection view. And the last step is to start to listen to the hub with start async. But when we are building an app like we are doing here, we also need to handle when the user navigates away from it, for example, and when it's returning to it, because we have a navigation stack. So views will continue to live in Xamarin.Forms, even if you leave them. So I recommend you to have on disappearing to stop listening to messages, so you don't have a view in the background updating messages. In this case, if you want all messages, it's better to save them on a server in a database, for example, and then you will get them there from there when you're returning back. So all messages that had happened when you were away, you will call the server to get them, not collect every message within your SignalR connection. So I think that is a good idea. And in on appearing, when we're returning to view, we will start listening to them again. And here I also have added a check if hub. So hub is not null, because on appearing is also running the first time we enter the view. We also have here, we check so the state is not connected already, or that it already is connecting. Then we can run hub start sync. We can also add some, if we make, for example, make the hub public and maybe static, we can reuse it on other places in the app, and we can also, in that case, handle it from on resuming and on returning, for example, in the app.xaml.cs file. So we can do like this. It's probably not best practice to have it in a live view model, and if you want to use it from multiple places in your app, you can place it on a better place. But I just want to show you that what you can do here. So on sleep, for example, we can do like this: live view model .hub.dispose, so we can dispose it when the app is closing. And I think that also is a good idea. And then we can handle on resume to create a new connection to have and make sure that the connection is up and running. Maybe you have a connection, SignalR connection, that is updating things in your app. You want live updates, but you don't want it to happen for a specific view. So then you need to have the SignalR connection running in the background, and then you cannot use on appearing, on disappearing. So in that case, I recommend you to use on sleep, for example, instead, to start and stopping messages. Then you should create a method that initializes it again in on resume. So you make sure that you have a fresh and non-disposed object. Because if I do like this, start, I think I will probably get an exception that the hub is disposed. So let's run this again. We can start the web application to get some updates. We can also do like this. We can start another mobile app client to show that you will get updates to all connected devices. Then I need to run it again. I have the web application here. like this. Make it a little bit smaller so we can have all the devices here together. Here we have Visual Studio, is still building the iOS app. Okay, when we're waiting, I can show you my blog where I had post about SignalR. So the easiest way to find that is go here to the tag tree and click SignalR. This is a pretty old blog post, but I followed it when I created my sample, and the information here is still relevant. So if you want to try this out, you can go to my blog or you can read the book. The book is much more details about how to set the things up. So here we have the other iPhone. It's a little bit slow to start. If you have any questions when we are waiting for that, I can answer them now. There, you can see there are discussion about what most Xamarin devs using for machine to work with Xamarin development. And David Orton is here saying that Windows is most present, but I like to be on a Mac when I develop, because I think that's is the fastest way to work with iOS development. So here we have the second client, Daniel2. Connect that to the live feed as well. Then we need to find the web window and have all of them open together. So we can update here. We can, hopefully this is still connected. Yes, it was. I had a breakpoint here. We can disable that one. Open that again. So we can update the bomb. And all devices are updated. And as we can see here, we have only the messages that we have got when it was connected to the hub. So it will not update with all the messages, but you can write your own code for that if you want to. And it's really, really fast. I really like the SignalR hub. Can build great applications with it. Yes, David writes in the chat, this is the visual material component. So I will get material design even on iOS. I think that's pretty nice, especially for the input controls. Let's check the chat if there are some other questions. If you have questions, you're very welcome to write them in the chat, and I will try to answer them. As I said before, it would be probably better way to have this code shared between all your .NET applications, your .NET clients, because this code is the same both for the Blazor WASM app and for the Xamarin app. But I have put it separately now because I want to share all the code together where I use it. So share library between your client and your app would be great. So you don't have to maintain multiple code bases. So are there any questions? Otherwise, I have showed you what I wanted to show you about SignalR. So if you want to know more, you can go to Microsoft documentation, you can go to my blog, and of course, you're very welcome to buy the book if you want to have step-by-step instructions how to set up SignalR Service in Azure and how you can build an app. In the book, it's a chat app, so you can chat with other apps. If you have questions later, you can send them to me on Twitter, for example. And you're very welcome to follow me on Twitter, read my blog, and also on Twitch, because there will be more live streams, and I will talk about Azure and Xamarin and Blazor stuff mostly. So here we have some contact information if you want to reach me. Yeah, we have questions here. We only need to deploy only functions app, right? Yeah, the function apps we need to deploy. This is the only thing we need to deploy. It's easy to do from Visual Studio. Just right click and publish, or you can add it to your CI/CD pipeline to handle that. But you need to deploy it to Azure. For SignalR, you don't need to deploy anything. You just need to add the connection string to the function app in Azure. Okay, thank you very much for your time.